Hello students, welcome back to our YouTube channel Geeks for Geeks, GATE, Computer Science and DA. In this video, we are going to discuss about Cayley-Hamilton Theorem. So till last class, we have discussed about eigenvalue and eigenvector. Just a minute. Okay, so till last class we have discussed eigenvalue and eigenvector, and one of the important thing we have discussed about characteristic equation, which from the start help us to solve eigenvalues and later on with the help of that eigenvectors. And then we have seen some of the properties which help us to find out eigenvalues. So but before that, before starting, I just want to give a quick revision for characteristic equation. So what was characteristic equation? Let's suppose A is a matrix of order n cross n. I am interested in finding out a vector n cross 1 which is not equals to 0, such that if I'll solve Ax equals to lambda x, I'll get, if I'll multiply this x vector with the matrix, I'll get a scalar lambda and the vector itself. That is a definition of eigenvalue, eigenvector. This is my eigenvector here. This is my eigenvector. And this is my eigenvalue. This is my eigenvalue. So one thing we have seen that to start solving with for the eigenvalue, what I have to solve? I have to solve determinant of A minus lambda I. If I'll solve this determinant of A minus lambda I equals to 0, I'll be able to find out my characteristic equation. This is what? This is my characteristic equation. Characteristic equation. So what it says? Cayley-Hamilton theorem says that every matrix satisfies its own characteristic equation. So that means if I'll replace lambda with A, it would satisfy. I am able to see here, I can replace lambda with A minus AI, A minus A would be 0. So that is my characteristic equation. Because further on we are solving this determinant of A minus lambda. I am getting a polynomial. If A is a 3 cross 3 polynomial, कुछ ऐसा मिल जाएगा, lambda cube A lambda square plus B lambda plus C. I'll get something like that, right? ऐसा कुछ मुझे polynomial मिल जाएगा. And this polynomial from where I am getting it from determinant of A minus lambda equals to 0. If I'll replace lambda here, it is satisfying. So if I'll replace lambda with A, it would also satisfy. So it would satisfy that if this is a characteristic equation, so it would satisfy A cube plus A square plus BA. Now what would I do with this C? C is not operative. I cannot do operation of C with A. I cannot add a matrix with a scalar. So for that we will multiply it with an identity matrix, because here as well, when we have a scalar, we have taken an identity. So that is what my Cayley-Hamilton theorem says that. So every matrix satisfies its own characteristic equation. That is my statement. Or it is reverse. If I have given a characteristic equation, matrix would satisfy. If I have given any matrix equation, then your characteristic equation, your eigenvalues would satisfy that. Right? So let's see. A is equals to 4213. So what would I do? I'll solve here. First let's find out the characteristic equation. A minus lambda I equals to 0. So what would I do? 4 minus lambda 2 1 3 minus lambda. I'll solve this determinant. 4 minus lambda 3 minus lambda minus 2 minus 2 equals to 0. 3 is 12 minus 4 lambda minus 3 lambda plus lambda square minus 2 equals to 0. So it would become lambda square minus 7 lambda plus 10 is equals to 0. Lambda square minus 7 lambda plus 10. So what this Cayley-Hamilton theorem says that every matrix satisfies its own characteristic equation. So it says that for this question, it says that A square minus 7A plus 10I is equals to 0. Right? I'll have this statement. So now with the help of this, I can solve questions further. But now I want to check that, is it really true? Is it really true? I just want to verify it. I'm just verifying it for my sake, but like in exam you do not have to do anything like verification, right? So I am doing the verification here only to check that is it really true, is it, if I'll solve this left hand side I'll really get 0 or not. I just want to check that. So what would I do? Let's find out a square first. A square would be 4213 into 4213. So on multiplication, what would I get? 4 4 16, 17 8 10. 4 2s 8 and 3 2s are 6. That means 14. 4 plus 3 7, and then we'll have 2 plus 9. That would be 11. That is your a square. Now let's take the right hand side. That is a square minus 7a plus 10i. So what I am writing, I am just substituting all the values. I am substituting a square 18 7 14 11 minus 7. That would be 4 2 1 3 and plus 10. Identity 1 0 0 1. I need to check that. So let's check 18 14 7 11. I can take 7 inside. 7 4s are 28. 7 2s are 14, 7 1s are 7, 7 3s are 21, plus 10 I am taking outside, inside 0 10. Now further I'll get 18 minus 28 plus 10, 14 minus 14, 7 minus 10, 7, 11 minus 21 plus 10. So what would I get here? I get a 0 matrix. This is my 0 matrix. So when I'm writing a square minus 7a plus 10i, so if a is of order 2 cross 2, then I is identity matrix of order 2 cross 2, and 0 is also it is a matrix here of order 2 cross 2. It is not a single value, because if I'll do any operation on a matrix, I'll get a matrix in return. There would be a single 0. It would be a 0 matrix of order 2 cross 2. Right? So that is my Cayley-Hamilton theorem, that every matrix satisfies its characteristic equation. Right? And we have done the verification as well. If you would take a cubic, that would get really lengthy, because then you have to find out a cube, but it would verify it would be applicable for any order. Now let's try further some questions based on characteristic equation. This is a question of GATE exam. A is a matrix given to you, the matrix a to the power 4 they are asking using Cayley-Hamilton theorem. Now this is a 4 cross 4 matrix. If you try to find out a square, a cube, a की power 4, it would get really lengthy. So what would I do to solve it? Think about it, guys. What would you do to solve this question? You have to find out this a to the power 4. So what I can try to do, I can just try to find out its characteristic equation, and once I get the characteristic equation, can I get some operation on a? I'll replace lambda with a. Every matrix satisfies its characteristic equation, and then I can see that what I am getting to get to the results. Right? Let's try to do that, because they are also showing it as Cayley-Hamilton theorem, and this question is like they have asked in like in early years of GATE exam, because then they have asked theoretical question. This is a theoretical question, because here it is not a NAT, it is not a numerical answer type question, because when you solve a to the power 4, it would be a matrix, not a single value. Right? So for that, what would I do? I'll find out my characteristic equation. A minus lambda equals to 0. I'll solve this for this 4 cross 4 matrix. देखो वैसे 4 cross 4 matrix के लिए it would get really difficult to solve determinant of a minus lambda, but it is a upper triangular matrix, so it would get really lengthy. It would get really easy. So what would I get? 1 minus lambda 0 0 1 0 minus 1 minus lambda 0 minus 1 0 0 I minus lambda I 0 0 0 minus I minus lambda equals to 0. I need to find out this determinant, and we know one thing, that when I have a upper triangular, lower triangular or diagonal entries, then the determinant would be only the product of diagonal entries. Determinant will be the product of diagonal entries. So what I can do here is, I can do 1 minus lambda minus 1 minus lambda and I minus lambda and minus I minus lambda equals to 0. Now I get this as my characteristic equation, but it is not a simple format. I just have to convert it into a polynomial. Right now it is in factors, so I am going to convert it into a polynomial. So let's do that. 1 minus lambda into minus 1 minus lambda, a minus b and a plus b, ये वाला फॉर्मेट ही बन रहा है. सो यू वुड गेट माइनस 1 प्लस लैम्डा स्क्वायर. ये आई इसको ऐसे लिख लो. अगर यू आर हैविंग अ कंफ्यूजन तो यू कैन राइट डाउन दिस एज, ठीक है, वैसे तो मल्टीप्लाई करना है, तुम मल्टीप्लाई नॉर्मली भी कर सकते हो. तो यू वुड गेट इट एज माइनस 1 प्लस लैम्डा स्क्वायर, माइनस 1 प्लस लैम्डा स्क्वायर. जैसे मल्टीप्लाई करी कैसे मैं तुम्हें बता देती हूँ. 1 की मल्टीप्लाई करो माइनस 1 माइनस लैम्डा की मल्टीप्लाई करो प्लस लैम्डा स्क्वायर. what would I get? Lambda get cancelled, minus 1 plus lambda square. Similarly for the next one, iota is what? Iota is square root of minus 1. If I'll do iota square, that would be minus 1. So I'm doing the same thing here. Iota gets multiplied with this one. Iota into minus iota. Iota square is minus 1. Minus of minus, we'll get plus minus iota lambda. And minus plus iota lambda. And this lambda plus lambda square equals to 0. So these two terms get cancelled. So here I got lambda square minus 1. Here I got lambda square plus 1. Lambda square minus 1 into lambda square plus 1. Right, again a minus b, a plus b, simple format, a square minus b square. Either you can also multiply lambda square minus 1 square. So we will get lambda to the power 4 minus 1 is equals to 0, and I can say that, yeah, this is my characteristic equation. This is my characteristic equation. Now I got the characteristic equation using the diagonal entries of this matrix because it is a upper triangular matrix. Now next thing is, every matrix satisfies its characteristic equation, Cayley-Hamilton theorem. So I'll write down here that a to the power 4 minus identity is equals to 0. So a to the power 4 is equals to identity. Right? So the answer here will be, it will be an identity matrix. So I told you na, it would not be an NAT. It would be a theoretical answer. Right? So this is my answer. So I think this question is clear to everyone. Let's try some more questions. Next question we have here is a4 to minus 1 1. Then they are asking me to solve a minus 2i, a minus 3i. Now you can solve this simply by substituting this matrix. You would substitute in place of a in place of a you would substitute 4 to minus 1 1, and you would minus 2 identity 1 0 0 1, and same thing you would do for a minus 3i. Right, you would get the answer. दोनों से you would get the same answer, but right now I am interested in solving using Cayley-Hamilton theorem because I have studied that topic. So I am interested in finding out the solution using Cayley-Hamilton theorem. So what would I do? One thing you can check that what would be the roots of eigenvalues. What would be the eigenvalues for this matrix? मतलब मेरे को I need to find out characteristic equation, but मैं direct characteristic equation बनाने का try कर रही हूँ, not using the longer method determinant of a minus lambda equals to 0. I am trying to directly finding out the characteristic equation because right here as well, these matrices are given in a factor form. So instead of solving it in a polynomial form, I am just getting directly factors form of my characteristic equation because then it would get less lengthy. Alright, so if I'll talk about the eigenvalues, sum of the eigenvalues is lambda 1 plus lambda 2 would be 5, and lambda 1 into lambda 2, product of determinant 4 into 1 plus 2, that would be 6. So what would be the eigenvalue? 2, 3. So I am just reversing the order. पहले मैं characteristic equation निकालती थी, फिर मैं eigenvalues निकालती थी. अभी मैं eigenvalues पहले निकाल ली and I am writing the characteristic equation corresponding to it. लैम्डा माइनस 2, लैम्डा माइनस 3, यही फैक्टर फॉर्म मिलती है मुझे. राइट, अब आई नो दैट एवरी मैट्रिक्स सैटिस्फाइज इट्स कैरेक्टरिस्टिक इक्वेशन यूजिंग Cayley-Hamilton theorem. Cayley-Hamilton theorem, I can write down a minus 2i into a minus 3i is equals to 0, and this is a zero matrix of order 2 cross 2. So here option 3 is correct. Option 3 is correct. you get the answer in 2 steps. Otherwise तो सोचो ना, if you try to solve it using the method, you would write down a 4 2 minus 1 1 minus 2 1 0 0 1. You get this matrix, and like I am just substituting a and identity in place of that. So I am getting here 4 2 minus 1 1 minus 3 1 0 0 1. I'll solve it. What would I get here? 4 minus 2 2 2 and minus 1 and 1 minus 2 minus 1. This is my this matrix, and इसको solve करेंगे तो 4 minus 3 1 4 it would be 2, ठीक है, and then minus 1 1 minus 3 minus 2. Now let's multiply these two matrices. If I'll multiply 2 2 minus 1 1 minus 1 0, this would be 0, this would be 0, minus 1 plus 2, that would be 0. So I got 2 cross 2 matrix, that is of 0 matrix, right? But it is a 2 cross 2 matrix, so we are able to solve. But if we have a 3 cross 3 or 4 cross 4 matrix, then it would get really difficult to solve it using this method. So that's why we use Cayley-Hamilton theorem. So but in this question it's up to you which method you want to use. Now let's see next question. Next question here is a 3 cross 3 matrix is such that p cube equals to p, then the eigenvalues of p are. You need to find out the eigenvalues of the matrix p. P cube equals to p is given, and they are asking you to find out eigenvalues of p. So once you know one thing, that every matrix satisfies its characteristic equation, reverse as well too. So lambda cube equals to lambda, lambda cube equals to lambda. So lambda cube minus lambda is equals to 0. Lambda into lambda square minus 1. Lambda would be 0, 1, 0 plus minus 1. So we can have these 3 eigenvalues. But in a class, one of the student asked me, ma'am, I have taken P is an identity matrix. P is an identity matrix, and for this identity matrix I am satisfying this condition, p cube equals to p, it gets satisfied, but the eigenvalues of I are 1 comma 1 comma 1, not 0 1 and minus 1. How have you said that eigenvalues would be 0 1 and minus 1? Now one thing what they say is that every matrix satisfies its characteristic equation. यहाँ पे जो होता है matrix satisfy करेगी, और जो भी तुम्हारी eigen value आएंगी that also would satisfy this matrix equation. वन eigen value आ रही है तो 1 cube equals to 1 हमेशा true होगा. Instead of अगर तुम ये वाली matrix ले लो 1 0 0 0 1 0 0 0 0, it would also satisfy p cube equals to p. It has eigenvalues 1 comma 1 comma 0 because it is a diagonal matrix. So all the eigenvalues जो भी इस तरीके की matrix होगी p cube equals to p, जो भी ऐसी like we'll have the matrix which satisfy p cube equals to p would have the eigenvalues either 0 1 or minus 1, because those eigenvalue would satisfy this lambda cube equals to lambda. They would satisfy. It would not always be true कि 0 1 or minus 1 ही होगी. If I'll take another matrix, let's say I'll take 1 0 0 0 minus 1 0 0 0 0. This is my p cube equals to p gets satisfied, but the eigen values here are 1 minus 1 0. अब ऐसे मत सोचना कि ये वाली जो मैट्रिक्स है ये हमेशा जीरो मैट्रिक्स ही होंगे, डायगोनल मैट्रिक्स ही होंगे, कोई और भी हो सकती है. देयर इज नो इश्यूज इन दैट, ठीक है. बट those matrices should have diagonal entries, should have eigenvalues either 1 minus 1 and 0, not any another value other than that. So I hope this point is clear, that you get what are the possibilities of the eigenvalue. Now it completely depends on the matrix that what exactly be the eigenvalues, but whatever be the eigenvalues you would have for that matrix, that would satisfy lambda cube equals to lambda, because Cayley-Hamilton theorem only says that Cayley-Hamilton theorem only says that कि अगर मेरे पास characteristic equation है my matrix would satisfy, और अगर मेरी matrix की equation है then characteristic equation would satisfy. इतना ही बोलता है वो. आइगन वैल्यूज की बात like it doesn't talk about eigen values. So think about it. And if you feel like there is any doubt, you can just let me know in chat section. Now let's try another question. So this is a matrix A given to me, 1 0 0 0 4 minus 2 0 1 1. The matrix A satisfies the equation 6A inverse equals to A square plus CA plus DI, where C and D are scalars and I is the identity matrix. Then they are asking for C plus D is equals to. So I am solving here by a longer method to let you know that how this Cayley-Hamilton theorem exactly works, right? And then later on we are going to try to have a shortcut method as well. But pehle chalo karte hain. You would solve for determinant of A minus lambda. First of all, like pause the video and try to solve it by yourself. Okay, then look up for the solution. Right, A minus lambda, so we'll get 1 minus lambda 0 0 0 4 minus lambda minus 2 0 1 1 minus lambda, and this determinant should be 0. So 1 minus lambda, I'm multiplying 4 minus lambda 1 minus lambda plus 2 equals to 0. So we'll get 1 minus lambda 4 minus 4 lambda minus lambda plus lambda square plus 2 is equals to 0. 1 minus lambda lambda square minus 5 lambda plus 6 equals to 0. But abhi bhi pura form nahi aaya. I'm just making the exact final form of my characteristic equation. So I'll multiply lambda square minus 5 lambda plus 6 minus lambda cube plus 5 lambda square minus 6 lambda is equals to 0. Now the characteristic equation would become minus lambda cube plus 6 lambda square and minus 11 lambda plus 6 is equals to 0. So can I write down this as taking negative to the right side? Can I write down that as lambda cube minus 6 lambda square plus 11 lambda plus minus 6 is equals to 0. So this is my final characteristic equation. This is my final characteristic equation. And I got this characteristic equation. Characteristic equation. Right. So every matrix satisfies its characteristic equation. So what would I write down here? A cube minus 6A square plus 11A minus 6I. Achha, guys, everyone know na how we got to know that I have to apply a Cayley-Hamilton theorem? Because you can see that I have given a matrix and I have given an equation in terms of A. In terms of A, I can only get the equation if Cayley-Hamilton theorem, like I'll apply Cayley-Hamilton theorem. So I'll solve this. So A cube, but abhi bhi yes form mein nahi hui. I can see that here they have written something A inverse. So what I am writing? A cube minus 6A inverse. मैं 6i को राइट साइड में लिख के जा रही हूँ और उसको ऐसे लिख रही हूँ. 6i इज इक्वल्स टू a cube minus 6a in square plus 11a. Right, just taking the 6i to the right side and the remaining one on the left side. Right, so I'm multiplying a inverse on both sides because left hand side is 6a inverse. So I'm converting it into that format so I can easily compare. It would become 6a inverse a square minus 6a plus 11i. I get this. Now if you would compare this equation, 6a inverse a square ca plus di with this one, what would you get? You would get a ka coefficient is c and here a's coefficient is minus 6. So c is minus 6 and d is 11. They are asking for sum. C plus d is equals to minus 6 plus 11. That would be 5. So answer is 5. 5 is my answer. Right, so the answer is 5. So now it's completely up to you if you want to solve this method. Like one of the student told me, ma'am, I'll find out a inverse a square a and I'll substitute all that and then compare the values of c and d. That would get really lengthy. Okay, if you want to do that, you can do that, but because you have to find out a inverse, then a square, then a, and then you have to just solve it 3 cross 3 matrix. That would really get lengthy. So I'll not suggest to use that particular method. But also, like, there is one more method which is comparatively more easier, more time, like less time you would take in that method, because if you would try to find out the eigenvalues here, what would be the eigenvalues? Because it is a 3 cross 3 matrix, so sum of the eigenvalue would be lambda 1 plus lambda 2 plus lambda 3 would be 6, sorry, and product of eigenvalue would be lambda 1 lambda 2 lambda 3, what it would be? Determinant. So I'll solve the determinant जो हमने last class में we have discussed the properties, that's the same thing I am using. Just a minute. Lambda 1 lambda 2 lambda 3, so I'll find out the determinant. 4 minus of minus 2, 4 plus 2 6, so product is 6 and sum is 6. What can be the eigenvalue? Product is 6, sum is 6, so eigenvalues would be 2 comma 3 comma 1. If product is 6 and sum is 6, there is only possibility 2 3 and 1. So if I'll take the eigenvalue 1, अब देखो ये जो equation है, every matrix satisfies its characteristic equation, every equation gets satisfied with its eigenvalues because of Cayley-Hamilton theorem. So if I'll replace A inverse, इसको ऐसे लिख दो 6 by lambda lambda square plus C lambda plus D, ये बन जाएगा. Now what I need to 2 3 1, 3 are eigenvalues. I am substituting 1. अभी तुम देखना मैं क्यों substitute कर रही हूँ. lambda equals to 1, 6 1 plus C plus D. So on solving you would get directly C plus D is equals to 5. So there are 3 methods which we have discussed. One is that this longer method I am going to compare, then this is a shorter method, and then another longer method, that is you would find out A inverse, A square, A and D, and you would find out the values. So completely up to you which method you want to use. So I think these are all the questions we have, and this is a homework question for you, and this is not based on Cayley-Hamilton theorem. This is basically on properties of eigenvalue and eigenvector. It would give you more understanding, and the answer is also written here. Make sure you guys try to solve it by yourself and reach to the answer A, B, C, and yeah, try to solve it by yourself. And if there is any question or any doubt, you can just let us know in the comment section. And guys, whoever is asking for the one shot video, like I have seen some of the comments, students asking for one shot video. One shot video we'll like have it later on when we have to do revision, but right now you have time, so you can just go through all the topics completely, and you can see that we have in total 13 lectures. I think there would be 1 or 2 more lectures in which we have to discuss diagonalizability. Right, so I think each lecture is of around half an hour. So like if I'll talk about, so that would be around 7 to 8 hours content. So you can just binge watch that as well if you find interesting, and try to solve question by yourself. Okay, just take 2-3 days and try to complete it if you are starting from the first video. Right, if any one of you, and if you want to suggest your friends to go through this playlist. This playlist would be very helpful for linear algebra, and later on we are going to cover calculus and probability statistics as well. So for this video we are going to stop right here. That's we have for this video. Yeah, and in the next video we are going to discuss about diagonalizability. Okay, so that's all for this video, guys. Thank you for joining.